and today we are going to continue talking about the risk of predictive modeling. So in the previous lecture we have introduced the concept of loss function, and now we are talking about something more general, which is the risk in the predictive modeling. And as we introduced in the last lecture, it is just the expected value of the loss function. What does it mean, the expected value? It's not only the average, it's the average among all possible samples. Okay, it's like the absolute average among all possible samples or the whole population. And this is what we call as the risk, is the expected loss of a predictive function. So the loss of the predictive function, as we already mentioned last time, it's basically the difference or the discrepancy between the predicted value and the actual value. So don't forget, we have a data set, we have features, which are the input, and we have the output. And you would like now to make a model, a function J, that will map the features into the output, that will convert the features into the output. And you want to minimize what? You want to minimize the loss. Okay? And now, beyond the loss is the risk, which is the expected value. Imagine that you calculate the loss from an infinite number of samples. This average loss of all infinite number of samples, this is what we call the risk. And in practice, finding the risk is not possible, okay, because we don't have an infinite number of samples. But we can converge to that, okay, using the law of large numbers and the central limit theorem. We will converge to some statistical significance of this expected predictive modeling. And the equation is simple. So this is what we call the risk. E is the expected value. L is the loss between the real output and the predicted output. So this is how we model the risk. And one of the objectives of this course is, given a problem, you must be able to devise and find the loss function, the risk, and also the minimization that we will talk about. Okay. And okay, so the risk definition we denote it as L, okay, or sometimes R also is the expected loss, as already mentioned. And if we know the probability distribution between X and Y, okay, if I have the joint probability density function, I know all the possible cases X and Y as a probability distribution function. In this case, it's possible to find the expected loss. But in reality, we don't have that. In reality, we have a sample of data. Okay, so basically what we are going to compute, this is what we call it the empirical risk, okay, which is an estimate value of the risk, okay, which is R hat. So hat usually in statistics, okay, or in machine learning, it means predicted, or empirical. Okay, so this is an empirical estimation of the risk, which will be equal, instead of writing the expected value, which is not possible, it's just the average based on a certain sample size of size n, okay, and we make the sum of all losses over all the pairs yi and gxi. So we have a data set x1, y1, x2, y2, x3, y3, and so on. Okay, we're going to calculate the loss for the first sample, for the second sample, for the third sample. We make the sum of all losses, and finally we calculate the average. Okay, and this sum could be on individual values, or it can be also on batches as well. But let's take the thing simple. This is just the ith sample, okay, the true value yi, okay, and xi represent the observed input of the ith sample.